Hey everyone, welcome to Open to Public HVAC School. Today we're going to do a quick video over what these symbols are on your multimeter or clamp meter like this one, and what it is they do and what we use them for normally in HVAC. There are some you're not going to use as often, and we'll get to that in just a moment. All right, let's take a look. Now, what do these symbols mean? And I'll get to the different kinds of symbols and how it can be the same meaning. Also, there's some meters that go up higher than this one, but I do have customers and technicians that will come in and have these really simple meters you can get on places like Amazon. They're going to be different than what many people use in the field that are going to be doing this for a living. However, because of the fact that a lot of people get clamp meters or multimeters that look similar to this, I would take something familiar and show what all of these symbols mean. Okay, so section number 1, you see how it has the symbol next to it. This is the amp draw. And this shows us exactly how many amps, say your compressor or your fan motor or a load that you're measuring off of any sort of power source, this is going to tell you exactly how many amps it's pulling. And then you're going to look at that sticker on your motor or your compressor, and you're going to find out if it does line up. Now, usually when you're doing a lot of things in HVAC, you're going to go over 40 amps. Smaller things like motors and whatnot, they usually don't go past somewhere between 11 all the way down to maybe 1.2 amps, something like that. If you're going to go larger, you would turn it to this right here. So this simply means it can measure amp draw off of larger amp draws here, and then of course smaller amp draws. You're going to be using a meter that does have a clamp like this. When you're measuring amps, that wire should be centralized as much as possible within the meter so it does get a correct reading. But for now, we're going to go ahead and take a look at what these other symbols are. So on most clamp meters, these symbols are fairly universal right here. And as you can see, we have the V with the dash, and then the straight line, and then the V with the tilde or curved line. The V is going to stand for voltage, and above that is the symbol for DC, or direct current, and AC, or alternating current. Here in the US, most of the time you're going to measure volts AC, and that just kind of symbolizes the alternating current there. Most of the time when we're measuring such things as PSC motors and compressors, those are going to be AC voltage. So we're going to use our two leads here when we're checking across our wires, our contactors, our capacitors when we're checking that. And in these instances with voltage, there's no polarity when using your leads on there, as long as we're touching one on each, and I'll show you what that looks like in just a moment. But for now, know that that symbol stands for volts AC, and some of the meters now will have it as actually VAC, or capital capital V, A, C, something like that. And then, V, D crystal, not B, which is volts DC. So when you're measuring current, keep in mind that you need to know, especially when you're checking for voltage on, certain ECM motors. Those are all going to run off of DC voltage, but normally that's going to be through a rectifier board, which in a lot of ECM motors, it's actually on the inside where it has a module connected to a board, or the board is the module, and that's going to use a rectifier within it to convert AC to DC voltage. However, just know that these can check both. And that's what those symbols mean. Next in line, usually these are grouped together. That's going to be your ohms, your continuity, and diode. And that's what these symbols stand for. This is used for testing resistors or diodes that you see on top of capacitors and whatnot, control boards, and you have to have the correct lead on the diodes when you're testing them. So for right now, we're just going to leave it at that is diode, and this is continuity, which we've covered in other videos on what you're looking for, which is less resistance across your poles, your limit switches, what have you. You're testing to make sure that there is low resistance on that continuity so that it is good, or it's making good contact, like in the case of contactors. It's extremely helpful, and technicians and homeowners use this a lot. This symbol right here is represented in different ways. So as you can see, this is going to be your symbol for capacitance, microfarad. That symbol can be seen as a UF, which is microfarad. And then you can also see it as MFD, which is also microfarad. And then we have this symbol right here for capacitance, which looks something similar to this. So when you see this symbol, it means you have a meter that can read microfarad or has the ability to read capacitance. If yours doesn't have that, you can refer to my other videos on how to test a capacitor without having a meter that reads microfarad. But again, these symbols all mean microfarad. So if you see any of these on your reader, your multimeter, your clamp meter, that's what those stand for, and that's what they're used for. Interesting fact I actually found out recently is I always wondered why they separated ohms and continuity, because it is measuring resistance. What it essentially boils down to is continuity makes a beep. When you turn it to just ohms, it does not make that beep. In any case, when you turn to a setting with your rotary dial here, once you know you're on the correct setting, it's always better if you have a meter that has more than one symbol on it to hit your function button to cycle through. So for example, this is on ohms. When I hit function again, there's our diode. When I hit function again, there's our continuity symbol with the ohm symbol at the bottom. So make sure that you do have it on the correct setting. If you don't want to hear that beep, you just go back to this symbol being here with the ohms at the bottom. Personally, I like the beep because it lets me know that it does have a connection and that it is closed. What you're looking for here, and this goes for anything that needs to have a low resistance connection, because electricity likes the path of least resistance. Therefore, we want the resistance to be low. So on, say, disc limits that you would find in your furnace or your blower housing in HVAC, you put it across here, and as long as it is reading low like that, and you can hear how that beep could be annoying for some people, depending on how long you need to hold it there. That's, I could see that. But obviously this is good. It's good, it's snug, no loose bits. The same when you're testing your contactors, you should get an OL symbol on there when testing before it makes connection, because it should not have, and this is why I like the beep, it should not have a beep on these poles, because contactors and most relays are in fact open on startup before it gets that control voltage to use that electromagnetic mechanism and pull this in. So you should always be reading open on switches like this. And in your wiring diagram, which we can get into all that technical mumbo jumbo later, all it's telling you is that these should be open. So if you were to go to my other video where we test contactors, I can actually post the link below so you can check it out and see what it should be reading across when connected. Like we were just getting into, it needs to be the path of least resistance here. So obviously I'm holding those in. It's not going to get a perfect reading. One other thing to note, besides obviously being on the correct setting when you turn it, on your meter, let me get my other meter so I can show you. Common is black normally on just about every meter I've seen, but you never know. Could be some strange ones out there. Let me grab that for you. I want to see, obviously you can tell in here it's got more bells and whistles, but this thing is pricey and not everyone wants to throw, $100 and some odd towards a meter, unless of course you're going to be, working in the industry. But you can see what I like about this one is it actually points out common and then that positive symbol. One of the things that is important, because even I myself have done this when testing things, you need to make sure that your connectors, need to clean the inside of that one a little bit. Guess it's been a while, but make sure your connectors are completely in there, pushed all the way in so that it makes a good connection, good solid connection. You can see they are quite a bit longer, so it bothered me when I saw that. I could clean that up a little bit. Anyway, just make sure, depending on where they're located on your meter. For example, this one's here on the bottom. They're all going to have that standardized connection, and they need to be pushed in completely. You need to have that satisfying feeling of it pushing in. Now, I know a lot of you don't want to read manuals, but I recommend to familiarize yourself with the manual when you get meters, especially because not every brand is the same. They're going to have, like we're showing you with these symbols here, they're going to use different types of symbols that all mean the same thing, and it can get confusing. Just like with this one, it lays all this stuff out, what these symbols mean and whatnot, but who the heck wants to read those? So just to familiarize yourself with it, understand that these are the same thing. It just goes up to a higher amp draw. This one is going to be that straight line or direct current. Get my camera to cooperate there. But anyway, this is the direct current DC straight line. And then, of course, alternating current volts AC. These, again, remember when you turn your meter over to whatever setting. If it has more than one setting here, it's just a good practice to switch it over to which one you need. And it will always have a symbol somewhere on your screen of what it is you're looking at. So just make sure, and some of these will have settings, you know, like there's a backlit screen. You know, if you're somewhere dark, you need to be able to see. Or sometimes people just like having that light. It's comforting. It's nice. And then, of course, min-max, just like you see on this one that's been abbreviated. This min-max, what this is doing is when you're going to clamp your meter around your wire, when you're doing an amp draw, the max setting, when it's turned to max and you're on your amp draw here, what that's going to do is it's going to tell you what the highest amp draw is it detects. So after it sits there for a while, and you're going to need to push your hold button in like that so that it's going to tell you exactly, see how it's now on your screen, it's going to tell you what the highest amp draw is on load. So that way you know if it's drawing more than it should. And then of course if you're on, and you know what that highest spike is in amp draw. And then of course min is going to tell you what the lowest is, as well as if it's a dropping voltage. So it's really handy when you're doing amp draws to check it out. You know, for example, like compressors and whatnot, just seeing what it's doing. So whether you're wanting to get something simple like this, as I said, if you're a newer technician, you're just kind of getting this to go through school or starting off, because let's face it, tools are extremely expensive. Whether you want to spend somewhere between $16 to say $40 for a cheaper clamp meter, which honestly, unless you're just wanting to have this super duper fancy sort of thing and you know you're going to use it often, yeah, sure, you know, you could validate maybe spending somewhere between $130 to $160 on this. But for most people, something like this or similar to it, it's going to be a handy tool and something that can really help diagnose as you're going through your troubleshooting steps. Obviously, this lets you know what's going on with things you can't see. Armed with something like this, you'd be able to tell more about what's going on and therefore getting to the bottom of what could be causing, say if you're getting burned wires often on your capacitor coming from your compressor, you know, this would let you know it's overamping, something's going on there. You would know if it's not a consistent issue, say for example, putting your meter across here on load, seeing if it is making a good contact or connection with the meter, so that way you know if it is actually getting low resistance. Because what's great with a meter, especially one that can read microfarads like that, which again, we do have a video that shows how to do that with a normal clamp multimeter versus having something that does read microfarads, which this one does too, but you know, yours might not. It just lets us know that if it's showing to be good, even with a normal ohm meter or multimeter on specifically say a capacitor, what this is going to tell you, with the link below as well, to show you just a simple formula to figure out if your capacitor is good and within tolerance. This lets you know not only if it's open, but if it's low. So even if it were reading correctly with your ohm meter and your clamp meter, doesn't mean that it's not low, which could really frustrate someone trying to diagnose their condensing unit when their capacitor might be too low of a boost on startup to actually kick over your fan motor or your compressor, or both. Also equally frustrating could be the fact that, you know, voltage across these might not be correct, the coil is slightly burned in there. You know, it's a number of things. So these are really handy as a homeowner to be able to have for your indoor and outdoor units. Anyway, guys, hope this has been helpful, and hopefully if there's, I've covered most of everything. If there's anything you want to know or something that you feel like I haven't covered, just leave a comment below and I will do my best to get back to you as soon as possible. Have a wonderful day and a great rest of your week.